And the motivation for coming up with this research was, we know that HEVC can do twice as well compression in time. We know that there may be value to getting, twice the quality or half the bandwidth over time. But really, at this point in time, and then projected out over the next 5 years, what are the actual dollars and cents? Where does HEVC make sense now? Where does it make sense aspirationally? What should you be doing now? What should you be looking at later? And are there actually business models that can be enabled by HEVC, just as HD was with MPEG-4 or AVC, where it becomes you must do this now or you will lose revenue? So that's really what we're aiming to look at with this presentation. Why Frost & Sullivan? We cover a fairly wide range of digital media technologies, everything from acquisition to rendering. We do it on the enterprise side, house of worship, education, government. We do it on the media and entertainment side, pay TV, broadcasting, online video, and so forth. And so when we're presenting our findings today, they're drawn from this entire base of research. Why is my opinion somewhat reliable? I cover all the markets that are circled in red. So it's not just the video encoding and transcoding. It's also the protection, the monetization, the CPE, the consumer devices, the intermediate transmission technologies, the advertising side. So when these findings are drawn, again, they're drawn from a broad range of perspectives, and we try to connect the dots in a way that makes sense for the whole industry. So this is what we'll be talking about today. I'll quickly go through the value proposition of HEVC. I'm pretty sure it's very familiar to everyone here, but just one more time for clarity. We'll talk about the missing puzzle pieces, and that's a part of it that I think sometimes gets lost in the noise, is that it's not enough to have an encoder and a decoder. There's a lot that has to go in within the pipeline to make everything work. We'll talk about the different factors that we want to take into account when we're calculating the ROI, and then we'll dive into real-life business cases. And they're drawn from broadcast or 4K OTT, so we'll have a good mix of data. And then we'll finally conclude with what the implications are, not just for the vendors, also for the service providers, and then for the ecosystem at large. Stop me if you have questions at any point of time. And if I start talking so quickly that you can't understand me, just flag me down. I've been known to do that. So what are the motivations for HEVC innovation, right? There's actually 4 distinct players in the ecosystem. You have the CE device manufacturers, the smart TV vendors, the tablet vendors, the phone vendors, for whom video is a killer application. And they're fighting in a market that has maybe 3 to 5% profit margins, by and large. I mean, not the smartphones, but by and large. And where one device can make or break your entire product line. So HEVC is a really good way for them to innovate, differentiate, and start to become a little bit future-proof. If you look at the encoder vendors, we've seen AVC prices erode maybe 20, 30% year over year. And so how do you start to restore a price point? How do you start to restore the ability to innovate through profit? HEVC is a relatively new area. It's a very strong area to differentiate in. Commodity chipsets, commodity R&D hasn't caught up. And so it's a very good way to start to reestablish those credentials for encoder vendors. For the pay TV service providers, they're caught in a death battle of price on one hand and trying to get as much content out on the other. HEVC is a way to perhaps optimize the use of their infrastructure, perhaps improve the bottom line, perhaps improve the customer experience, but more importantly, to cast a wider net. If you can start to get HD to a larger number of users, especially in the rural areas, even in the US, or if you can start to get video in larger quantities without hitting data caps on a worldwide basis, these things start to make a huge difference to the business. And for online video service providers, it's a great way to start to differentiate with things like 4K. We'll talk about how, in a minute, the actual bandwidth savings aren't a huge differentiator here, and we'll look at why. But the idea that you can get new business models out, or again, that you can reach broader audiences, that's a big differentiator. So a lot of people, back in 2012, HEVC was the next best thing since sliced bread. AVC was about to die. HEVC was going to take over everything. We said then, and we're still saying now, that this is going to be an evolution, not a revolution. These are the predictions I had made back then. Fortunately for me, I was by and large correct. But what we've seen is these things come to fruition. So we have seen early apps like video conferencing, FaceTime probably being the one I would have least imagined, and yet, the one with the widest footprint right now. We're seeing others like Video and Cisco start to put it into their product lines. Low bandwidth VOD didn't quite need to happen because with 3G and 4G and LTE, the data transmission costs were already fairly low. But we're starting to see HD go out to a lot wider net of devices than it could have before. We're seeing DTT standards start to adopt HEVC. We're already seeing DTH services, 4K services, pay-per-view services. They're all starting to get rolled out. The numbers aren't huge yet. They're not going to be for a while. But the important thing is that we're starting to see production-grade models, production-grade rollouts. Even if you're in the millions of subscribers right now, that's a good thing, because when the upslope comes, it's not going to come with warning. It'll be one disruptive device or one disruptive encoder or one disruptive app, and it'll all start surging. But the groundwork is being laid now, and that's important. So that brings us to the middle of 2015, where we are now. If you were at NAB, you've seen a slew of announcements, STBs, chipsets, software-based players. These are good steps forward. I still don't think we have any broad rollout of HEVC. We weren't expecting to see it before 2016 anyway. But here we are in mid-2015, and things are starting to look pretty good. So, in terms of baby steps that we've seen in 2014 and 2015, the patent pool was announced by MPEG-LA. As we'd been predicting for some time, the terms weren't onerous. This is designed for adoption. There is a little bit of wrinkle in that, the HEVC advanced pool has been announced, but their terms haven't been announced. We have good reason to believe, and Dan Rayburn's blogged about this extensively, under the expectation of RAND terms, it's not going to be, pay us $40,000 per encoder. So, yeah.
Why are there different patent pools for HEVC?
It's not unusual for that to happen. So all that a patent pool is it's a group of companies who have intellectual property stake in the standard to come together and offer one-stop shop licensing. It's fairly unreasonable to expect that every single vendor will agree to be part of the same group. As long a history as MPEG-LA has through MPEG-2 and so forth, there have always been outliers, and most standards will have more than one patent pool. I think where it gets somewhat worrisome from my analyst perspective is when you have an announcement of a pool without any indication of what the terms are going to be, because that starts, CFO saying, hey, this is, we don't know, this is a red herring, let's hold off, let's wait. Unless you're a company with deep enough pockets that says, whatever, we'll figure it out in the courts. So that type of open-ended patent pool announcement I find worrisome, but in general, the existence of multiple patent pools is not unusual. Does that answer your question?
That's fine.
Anyone else? Okay. So we've seen the first HEVC-based 4K live channels deployed. They've been sort of not really 24/7 channels. They've been tied to specific events. But the proofs of concepts have gone well. They've gone well when every stakeholder in the chain is press releasing that they've done these deployments and that they were successful. Interestingly, the Olympics will not be broadcasting in 4K. And that's fine. We will still have, I think, select transmissions in 4K. So maybe it's not there tomorrow, but it's on its way there. And that's the idea. Is we're in baby steps mode. You want to be prepared to unleash it when the time is right. We've seen the first HEVC-based contribution systems deployed. So are folks familiar with the idea of closed-loop applications versus broadcast applications? Does that make sense? Okay, so a closed-loop application is something like contribution. You've got a camera, you've got an encoder. It goes to one decoder, it's decoded, and then it's processed. That's a closed-loop application. Broadcast is where, let's say you're BBC and you're broadcasting from a tower, or you're Comcast and you're broadcasting out of a head end, the same stream to multiple subscribers. So you have many, many set-top boxes receiving the same feed. Changing formats there is expensive, but changing them in closed-loop applications where it's 1-to-1 or 1-to-10 is very easy. At the same time, those are typically the applications where you're paying the most for the bandwidth, if you're using a satellite multiplexer or whatnot. And so those are the applications where we always expected the changes to come first. You have more control. It's a closed-loop system. We've started to see that. We've seen multiple deployments. We've seen multiple vendors enter the fray. And again, it's good baby steps moving forward. we're seeing tremendous growth in power-efficient HEVC decoding. This is something I had not expected when I first did this in 2012. We're seeing almost 5 to 7 hour battery life. There's smart clocking, there's smart threading. People are getting really good. Well, the phones themselves, in all honesty, have better chipsets now than we had expected. And so if you have a mid to high range phone, or if you have a modern tablet, you can expect to do a reasonable length of HEVC decoding in software. And finally, it's starting to get built in. Notice I haven't said HEVC built into the iPhone. I know it's being used for FaceTime, but it's not available as a general interface. And so, from my perspective, it's not on the iPhone. Someday it probably will be. But it's in the Android Lollipop, and that speaks to the growing ecosystem. It's in new chipsets. It's in new smart TVs. DivX in particular has been doing a number of announcements and rollout. And so it's good to see that. I expect to start to see it in streaming devices as well, sooner than later. No one's actually announced support yet, but I have a good sense it's going to be imminent. So what's the value proposition for HEVC? It's, on one hand, you can do better, yeah?
Just a quick question on the previous slide. What are the software players you're talking about? Your names?
I do. I'll give you a list right after, because I don't know which ones I'm allowed to release and not. I mean, it's the usual suspects, but I'll just give it to you offline.
So they're not public release, these are coming?
I don't know. I know I've talked to them, and I'm sure they are. I mean, I know the DivX plugin is public, for example, and the X.265. I'm sure the others I just don't know, so I'll catch you offline. Right, so there's a couple of things. Now, with the value proposition of HEVC, it's a lot of what we hear is, oh, you can cut the bandwidth by half, your bandwidth transmission costs will go down by half. That's great. Usually what's more interesting is you can double the quality in the same bandwidth, because operators are currently fighting on quality. And we'll get to that in a minute in more detail. It's also improved productivity through better quality video. So not in the M&E sense, but if you're using video for diagnostics, or if you're in a military application, command and control, the better video you can see, the better decisions you can make, remote training, remote troubleshooting, remote education. And in those types of applications, the HEVC can add a level of productivity without increasing the level of infrastructure. It's also lower CapEx or OpEx for the same content volume. Obviously, if you can shrink it in half, or even if you can shrink it by 30%, which is more realistic today, you're going to spend less selling it. I will say this. If you look at Dan's projections for CDN costs, the rate at which CDN pricing is coming down is arguably faster than the rate at which HEVC is getting better in its compression efficiency. So we'll reiterate this throughout the talk, but look at all your options when you're looking at reducing costs. Sometimes renegotiating your CDN pricing is a lot easier than switching to HEVC codecs. But nonetheless, when you can slash backhaul costs, if you had to add an extra channel to a satellite multiplex and drive your bill up by $1 million a year, at that point, yes, if you can get 20% better compression, that's a huge gain. So when I started covering HEVC back in the day, all these pieces were black. Other than the standard, there was no component available. Over the years, we've started to see more and more flash red. We've got a decent set of software cores, decent set of hardware cores, decent set of encode-decode products. The delivery products aren't quite there, and because they're not quite there, the services aren't quite there, but it's going to come. Some will bite the bullet and just roll out their own apps, or start to invest more heavily in the devices. More likely what's going to happen is you'll have multiple formats shipping. So even though AVC is the primary codec right now, HEVC support is shipping in these set-top boxes. Once you have a decent seat available, you can flip the switch. All right, so all that said, what do the numbers look like, right? HEVC enabled encoders only accounted for 1% of total encoder shipments last year. There were a larger percentage of HEVC capable encoders, and that encoders that could be upgraded in software in the field to do HEVC. Now you have to remember HEVC is more complex than AVC, so for a 4-channel or a 6-channel AVC implementation, you'd get one HEVC implementation, okay? So the per channel numbers are still not that strong, but the important thing is they're growing. 3 times as many encoders as were sold last year are in trial this year. So, we're expecting to see a gradual step up. Again, there will be a surge at some point of time. There will be a killer application. Everyone will jump on board. But for now, this is where it is. Also, CE devices. So 1 out of 3 CE devices that shipped in 2014 were capable of running HEVC. But any video service has to reach all deployed devices, not all new shipped devices. And that's a distinction I'll continue to emphasize. It doesn't matter if half of new devices shipped support it, if all the existing billions of devices don't. All right? And so same thing with TVs. 7% of shipments supported it. But if you look at the total deployed base, it's still a rounding error. And so the point being, it's growing. But the OVPs are not going to support it, and the DRM vendors are not going to support it until these numbers start to look a whole lot better. Any questions?
What CE devices are we including in that?
I'm doing everything except laptops. So tablets, smartphones, video-capable feature phones, set-top boxes, gaming consoles, streaming media devices, and one more that I can't remember. Yep.
And when you say set-top boxes, are you referring to every business, satellite, terrestrial, cable, or just one specific business?
No, all of them.
All of them.
All of them. It's just the numbers for set-top boxes. Smartphones dominate everything else. So everything else is factored in here. But the percentages are very sensitive to smartphone percentages. If you need a more detailed breakout, I can get them to you. Just give me your card afterwards, and I'll send them. All right, so it's great. You can do better quality. You can get to better folks. You can save millions of dollars on backhaul. How important is this? And this is where the rubber is still failing to meet the road. So if you talk to the encoder vendors, there are select trials, but they're more interested in building out bandwidth. They're more interested in getting their businesses up and running than they are in saving on OTT transmission costs for the time being. So when we did a survey with the CEOs and CTOs of media companies, these were the 4 priorities we got. They're worried about monetization. That's analytics, advertising, targeting, metrics. Just, can we get the sub fees up? Can we get the PPV numbers up? They're worried about digitizing their workflows, converting them to IP, maintaining the security, tying all of that to user directory protocols. They're worried about content protection, DRM, piracy, safety in the cloud, secure file transfers. They're worried about content management. Can we tag our content? It's 9 a.m. Do I know where my content is? How am I going to transfer and collaborate across distributed workspaces? They're not really worried about taking 10% off of their OTT bill for now. And I think we were talking to some operators yesterday. They're actually increasing the bandwidth at which they're transmitting OTT data so that they can send more beautiful video. That to me doesn't speak to an industry that's chomping at the bit to get its OTT bills down. But that said, there are cases where you have immediate ROI. One of them is 4K. If you do the math, it's about $500,000 to roll out a 4K service in the smallish volumes that we're seeing right now. You can usually do a $6 to $8 transaction. It takes you about $3 to transmit the video at 5 cents a gigabit, which is a relatively high CDN rate. All said and done, by the time you do 100,000 transactions, you've broken even. Everything after that is profit. It's a new business model you don't have right now. Now, how easy it is to get 100,000 transactions, it depends on the bandwidth. You don't have a whole lot of subscribers who have the bandwidth to get 4K. If you can, download it offline and then have them view it later, that's an easier proposition. You also don't have a huge decoder footprint. We kind of talked about that, but those are surmountable problems. Ultimately, it's not hard to start making money on 4K if you do it right, is the point here. It's also in terms of the sports and cultural events, that's where we're seeing a lot of the interest in 4K. So do you need to see the Jimmy Fallon show in 4K? Probably not. But the Indian Premier League in 4K is awesome. That's when, though, the bit rates start to be really high. It's hard to do a good 4K 60 frames per second or 120 frames per second broadcast at 12 megabits per second. ain't happening. So you need to look at the bandwidths, you need to look at the feasibility. But there's money to be made here, and that list is getting longer and longer. As you can see, about 3 new ones this year alone. Actually 4, I should have starred China as well. And that number is going to grow. So what are the challenges to 4K profitability? For one, still, and this is a contentious number. I know I say less than 10%. Some people say it's less than 5. Some say it's less than 25. Let's just say it's a small percentage of users can currently get 4K live, especially in the higher end use cases. So how do you solve that? You can compress more aggressively. Obviously, you can always drop the bandwidth. You can amortize costs across the upgrades. So if you're adding new HD customers, add them 4K enabled. It starts to bring some of your upfront capex down. You can always download rather than stream. If it's VOD or rental, you can just send it out overnight, store it on the hard drive, assuming you've got a set-top box with enough storage, but that's an easier problem to solve. And then we're also seeing a growth in streaming to multi-audience venues. So just streaming music concerts to digital cinemas, for example, which are already wired for that kind of bandwidth. So there's different ways that you can make money here. The other big issue we have is lack of a consistent decoder footprint. As we looked at, you don't have a whole lot of clients that are currently 4K capable. I mean, as many as are HEVC capable, even fewer are 4K capable. So one solution people have had so far is let's just lock it into a given smart TV. I'll only send it to Samsung, or I'll only send it to Sony. That's nice in theory. It irritates a lot of customers. It leaves others out in the cold. And if there's one lesson there is in OTT, it's unless you have ubiquitous access, consistent access, you're not going to grow very fast. I call it the Netflix lesson, but you have to be everywhere. You have to be consistent. That's when you start to see your numbers grow. The flip side of that is you just bite the bullet and you build your apps for every single device out there. That's a huge bet to make. It's an expensive bet to make. On average, it takes about $250,000 to $500,000 to build a secure app on every single consumer device if you're doing it from scratch on your own. There are ways to optimize that or amortize it, but it's still a big bet to make. You can also cap and grow 4K and HEVC support. I think in the long run, that's going to be the most sensible approach. Just start shipping set-top boxes with HEVC support built in now, 4K capability built in now. Over time, you'll have a critical footprint that you can then switch on. The last thing I want to talk about is the decryption sticks. So this is a little debatable in that, how many sticks and boxes do you ultimately want on a living room dashboard? But they've used this really well in Korea, and we'll go into that in a second. But you just have a decoder stick that plugs into an HDMI port. And it's an incredibly effective way to get a new decoder with very high resolution and actually a decent level of security onto legacy spaces. And you can plug that into a laptop, you can plug it into a smart TV, you can plug it into a number of regions. And for a very reasonable upfront capex, you get very broad footprints. So that's probably another fairly good short-term option. Over time, though, again, you don't want to have 50 million sticks on your desktop, so it's not going to be viable, but for now it works. 4K content and advertisements are a huge problem. They're just not there. And the last thing you want is to be watching a beautiful 4K movie and then flip to an SD ad that's been upstretched to 4K. It's awful. So that is a problem that will need to be fixed. The other issue is actual true 4K content. It's extremely expensive to produce. The systems to process it and transmit it aren't there. What they did with the Korean UMAX model was they all got together and subsidized it as a collective. So the cable operators, the programmers, have all pitched in to get all of this set up, to upgrade the networks. And that model is working really well. It's also created a positive feedback loop because now you have a reason to buy a 4K TV because there is a 4K service. And so suddenly you've reversed the whole negative loop of there aren't any receivers, so there isn't any content. That's working fairly well. Over time, we're starting to see, as we track cameras, as we track NLEs, the percentage of 4K is consistently rising. The transition to IP is helping with that quite a bit. So we'll get there. And finally, 4K bandwidths are the cost is a challenge even with HEVC. By the time you quadruple the amount of money you're spending on transmission, whether it's 3x or 4x, doesn't really matter. If the price point can't go up by that same factor, you're losing profitability. So does that make sense or not? That's where the business challenge is. And it goes back to that improved monetization priority that we discussed up front. Ultimately, that's what it boils down to. So HEVC and contribution and backhaul, and keep me honest on time, I don't have a timer here. HEVC and contribution and backhaul is something that's really catching on very well this year. And here's the reason why. So on average, this is what it's going to cost you to roll out HEVC-based backhaul for one HD channel. It's about 45K for the encoder, another 15K for a custom IRD, another 15K in services, if that. The encoder costs are falling, the IRD costs are falling. The backhaul bandwidth costs aren't falling all that much. And so if you look at the savings, it essentially pays back for itself within a year or two at the most. And then after that, you've got all the benefits of the improved infrastructure. And this is a closed loop application. Again, you control it. So the ROI is absolutely solid. The 5-year ROI looks even better. More importantly, you can start to bring HD feeds in from places you couldn't do before. So at 500 kbps, you can do a really, really good HD feed with HEVC. And the encoders are available now that can do low latency, high fidelity compression such that it can be a good contribution feed. So the business benefits, over and above just the cost savings are quite compelling. There's always a flip side of the coin. So the rack space consumption is going to be higher, the power consumption is going to be higher. Unless you buy a really high-end encoder, and those are expensive right now, the latency is going to be worse. And then you have to consider the value of your legacy equipment. Or if you already have a contract for a certain satellite bandwidth, then for the next 2 or 3 years, you're not going to realize these savings unless you want to double your channel count or something like that. So keep all those in mind. The other thing I want to point out is you can use OTT backhaul for a small fraction of the cost of satellite backhaul. And so if that's an option for you, the savings will be tremendously higher from that switch. You don't really even need to switch to HEVC. So just keep those alternatives in mind. Are there any questions on that before I move forward? Good. All right. So HEVC in a broadcast transmission, I realize this is streaming media, and we're not really broadcasters, but the economic model here has parallels in if you're sending OTT content out to millions and millions of subscribers. So just bear with me for a second. This was a use case in Africa. The model is from StarTimes research. The pricing is all my own. So this is not StarTimes. This is a price list. But what they were doing was saying, OK, should we build a greenfield transmission station using AVC or using HEVC? What are the pros and cons? So it turns out that the cost of building the station is approximately the same whether you use HEVC or AVC. The encoders are about 3 times more expensive, but you only need half as much transmission equipment. In this case, the video was such that they were actually getting the 2x compression efficiency. If you got 35 to 40%, if you had a lot of sports and whatnot, the numbers would be slightly off, but still the ROI is good. The magic is in the OpEx savings. This being Africa, power is hugely expensive. And so if you can cut the operating bandwidth by half, you cut the power expenses by half. And the ROI analysis is almost meaningless because you're basically raking it in from year one. The only caveat, as always, is the decoders. So either you send out HEVC-based set-top boxes, or again, you can do decryption sticks. But if you did the decryption sticks, even at a relatively expensive $50 a stick, you'd break even in the first year from the power savings, and then you'd be profitable from that point on. So this is where the bandwidth minimization starts, the bandwidth reduction starts to yield very, very concrete results when you have these large volume greenfield deployments. All right, this is probably the more interesting use case for our group. So this is HEVC at work in file-based OTT. We had a lot of discussion after the talk I did last November. And so I've tried to make the cost model a bit more explicit here. I'm assuming X hours of HD per household. That number isn't hugely important. It's also, I'm assuming 5 cents per GB, and I realize that's high. The only reason I'm doing that is it's not unreasonable, and the smaller I make it, the less the difference between the two, and so basically you wouldn't even see it on a slide. What is consistent is the ratio of cost reduction to percentage HEVC households. So let me take a step back and say this. Not all your households and not all devices in every household are going to be HEVC capable, all right? There will be use cases, and that's the percentage, that blue line on the right-hand track. There were no HEVC clients in 2014 of note. There are going to be maybe 5% this year, if we're lucky. But over time, it's going to trend upwards to maybe where you'll have 1 in 4 worldwide. I had projected this to 1 in 5 in November. There have been developments since then that lead me to believe it's going to be a little bit more aggressive. But even with all of that, understanding that AVC compression is getting better over time, just at a lower rate than HEVC compression, and putting in the standard numbers for bit rates and the numbers up here for cost, you're only going to save $2.50 per household per year in 2019 if you switch to HEVC. Now, if you could negotiate a better CDN rate, if you could go from 5 cents to 3 cents per gig, you'd have your CDN bill. All right? So just putting all of this in context, where this model doesn't make sense is if you're going to be able to reach 1 million new subscribers by using HEVC. So if you can get a service in a place where you can't get service right now, or if you can up a service to an area where you can't up a service right now, then the numbers are completely different. HEVC makes total sense. But if you're just trying to use it to reduce your transmission costs, don't do it. Renegotiate your CDN contract instead. Opportunity cost still matters. So, is there value to sending more beautiful video over the bandwidth you have available right now? Sure. Can you do it by maybe putting more processing power into your current AVC encoder? Probably. The ability to keep up with growing content volumes without upgrading infrastructure is a big deal. If you're seeing 3x, 4x, 6x growth in content volumes, as some folks are, even a 20% relief on the data bill may be something that you want to look at. But again, multiply it by whatever your volumes are, whatever your investment needs to be, and see if it makes sense. Converse considerations are similar to what we saw before. You're going to need more rack space. HEVC is more computationally intensive. For now, you don't have the hardware-centric encoders. For those who say they have hardware-centric encoders, ask them what the performance is. There's still a trade-off. There's a big trade-off. This is not a mature market yet. We're also seeing increased power consumption. There have been some vendors who've come to me and said, hey, we can do HEVC 4K channels at 6 watts. I don't have their compression efficiency numbers. So something's going to give for now. 3 or 4 years from now, it'll be a different story. The other thing is we've seen a lot of operators. Sorry.
You mentioned hardware encoders. What about software encoders?
So software encoders are currently doing the 3 to 4x power consumption. And so that's exactly my point, is if you have a high-density AVC transcoder right now, and if you're going to replace it with a similar capacity of HEVC encoders, you're going to have a monstrous data center. That density, that scalability is not there with HEVC yet.
When you're talking about density, you're talking about software-based solutions, right? And how do you define density? I'm looking at a 1 RU professional server, for example. Are you saying 10 cores versus 20 cores? Is that the difference?
No, I guess when I define density, I'm talking about how many channels can you push through, or how many minutes of video can you push through. Yeah, that's what I mean. So if you had to serve a certain volume of content or a certain number of users, how many rack units would you need? Sorry, I should have clarified that. So one of the big issues we see with the operators is they don't have physical space to grow their data centers anymore. They just can't keep up with the video. So having an additional parallel workflow, it's clear you're going to have to keep AVC. So you're adding HEVC, and you're adding these larger boxes for now. We also don't see a lot of support for HEVC in the cloud yet. It's coming, but it's not as mature or as easily orchestrated as the AVC solutions are. And so take all of that into account when you look at this. These are typical caveats to ROI. I'm going to breeze through these. They're fairly straightforward. Ask me if you have any questions later. But what's the actual compression efficiency? All HEVC encoders are not created equal, just as all AVC encoders are not created equal. So look at everything. Look at density, look at power, look at latency, look at compression efficiency. Take all of that into account when you actually do your calculations. Frame rate is another thing where we've seen a lot of fudging. Hey, I can do 4K at 12 megabits per second. Well, what's your frame rate? By the time you go from 15 to 30 to 60 to 120, the bandwidths quadruple no matter what you're doing on the compression side. Density and rack space we've talked about, hybrid we've talked about, decoder footprint we've talked about. End-to-end build-out and cost I want to emphasize for a second. When you're putting in an HEVC workflow, and I know it's popular to say, hey, we're using MPEG-2 transport stream, pull out one codec, put in another, no problem. What about your quality assurance probes? What about your advertising? What about your analytics? Are your fingerprint databases translated into the HEVC bitstream versus the AVC bitstream? There's a lot of end-to-end considerations. Are your post filters HEVC compatible? Can you keep the same player solution? Does your DRM system even allow the use of HEVC? If you have a secure video pipeline requirement, that's a whole other ballgame. So the end-to-end build-out and cost is entirely non-trivial. And the caveat for vendors then is, approach this with a systems integration mentality. Don't try to sell HEVC encoders as a point solution. This year, it won't work. And finally, keep in mind you're going to have parallel AVC and HEVC encoders. If you want to reach your set of users, it's not going to be HEVC alone. I'm going to skip this slide. If there are any encoder vendors, flag me later. But essentially, this is what you are competing on. There's a huge battle on for real-time encoders. If you can bring the latency down, the compression up, you're golden. Power-efficient decoders in huge demand, especially in countries where power is expensive. You don't want to have a high-wattage, high-fan device sitting there. Complete solutions are mandatory. End-to-end workflows are mandatory. There's no room for now for point solutions without either an end-to-end owned product portfolio or a very strong partnership story. So this is the take-home summary and recommendations. The ROI will vary if you have existing legacy equipment, if you have existing contracts in place, versus if you're doing something greenfield. If you're building something from scratch, you're very well off doing it in HEVC. If you already have an ecosystem in place, plan the transition carefully. We're seeing actually the only area that's really benefiting from HEVC right now is MPEG-2, believe it or not. We've had some companies report higher average sale prices for MPEG-2 this year than they did for MPEG-4. Because people are saying, oh, really? I can use those tricks on MPEG-2 and I don't have to change a thing? And so they have 4x better compression efficiency just from switching to a state-of-the-art MPEG-2 encoder. All right? And then they'll go to MPEG-4 and then they'll go to HEVC. But you want to get software upgradable devices to the extent possible. What you don't want to have happen, unless you're very sure it's right for you, is buy a hardware lockdown, can never change this once you buy it type of thing. Encoder and decoder vendors are innovating. They're getting more real time. They're getting more power efficient. Prices are high. They're really high, especially for good products. There's a lot of Me Too's. Prices will come down eventually. By 2018, we'll talk about that in a minute. We think they'll become comparable. But 2 to 3 years before HEVC will be as mature as AVC is today. And finally, I can't emphasize enough, I know I've said this 25 times already, look at all your options. Look at OTT backhaul, look at renegotiating pricing, look at just using better presets on your AVC encoders. Look at everything before you decide you have to jump to HEVC. And so I'll leave these predictions up there. They're fairly self-evident. If you have any questions, I'm happy to take them.
How does HEVC possibly affect delivery of services by, say, the cellular network? Does it present, video over cellular obviously eats up a lot of bandwidth. Does presenting it over HEVC either save the mobile operator money? Does it save the consumer money? Is there a cellular play here at all?
There could be, but you have to take the question in context. So is that particular telco or is that particular service using the best possible AVC compression today? We've had some people, believe it or not, send Windows Media Video over cell. For the life of me, I can't figure out why. So that's one thing. Is it possible to decrease frame rate? If you went from 30 to 15, would you notice on a phone? If it wasn't sports, probably not. And so again, yes, all other things being equal, getting 30% benefit would be great. but what's the cost of that rollout? And will you be able to reach every single device, or will you still have to have parallel workflows, and then what's the cost of that?
You haven't talked at all about HDR and that potential impact on television sales in 4K.
I was hoping you hadn't noticed.
I got to answer that question tomorrow, so I figured.
No, so high dynamic range is an interesting problem, right? So HDR, is everyone familiar with HDR? Yeah? All right. The issue, as I have seen it, and I was talking to Fraunhofer, they have a field programmable gate array they use, not a field programmable camera array that they use to get multi-view panning, and each of those does, an added layer of HDR, and they use it for color correction and whatnot. What I'm hearing is between the camera vendors and the post-production guys, the digital cinema guys, and the video research czars, they can't quite figure out what to do with HDR yet. They don't know how to capture it. They don't know how to normalize it. They definitely don't know how to post-produce it. And what they also don't know is how to splice together in any intelligent way sources that come from non-HDR filming versus HDR filming. So my takeaway from all of that mess is I think it's a source problem right now. Once they figure out how they're filming it, the downstream will fall into place pretty quickly. Because the Sonys and Samsungs and high-end and Vizios of the world, they know how to get that stuff done. They just can't implement 15 different HDR standards with any measure of profitability. So that's kind of where I'm seeing it right now.
I guess my question is that that's going to, I think it's going to mean that every 4K TV set bought for those standards are set is going to be obsolete really quickly.
Well, I mean, they're obsolete already, right? There's no 4K content. They're taking SD or HD content, upsampling it to 4K. How much worse will, some version of HDR be?
I mean, that's not really true because of the House of Cards, the original content. I mean, there's some 4K.
As a percentage of total content viewed, Jan, come on.
So you don't see the quick churn of 4K TV sets as slowing anything down?
I don't think anyone's going to churn the 4K sets. I mean, if you bought a 4K set to watch 10% of your content in 4K, you're not going to mind hugely that the HDR is not showing up. You should be a lot madder about SD content being upscaled to 4K. That's my perspective. I mean, yeah, it's going to be obsolete, but I mean, 3D TVs came and went, and they came and went. What are you going to do? No, I don't think it's going to hold up TV shipments. If anything, it might create a new cycle of refreshes. I doubt it will do that either, though.
Is there a view whereby, running down the path with 4K, HDR standard hasn't really been sorted out yet, but eventually that does get sorted out. And applying HDR to 1080p, if you've seen some of the demos, actually it's just almost as good as 4K, and therefore you can actually enjoy a lot of the benefits of that. So I think there's a view on that which people haven't really sunk their teeth into yet, so we may have to reconsider something.
Yeah. No, I think that's a fair point. And then you also get to the point where, if this is going to come over pay TV versus OTT, you're going to have to upgrade the set-top boxes too, because they're not HDR aware right now. And do you want to maybe start to look at increased frame rates also? I've heard that even at those resolutions, if you increase the frame rate, you get a really good experience. And so yeah, anything to not quadruple your bit rate, right? Did someone have a question in the back? Sorry, I'll get to you.
HEVC encoders, I mean, in your experience, do you think the compression complexity and maturity is there right now? Do you think it's getting better?
You have a choice. You can get a very mature encoder if you're willing to pay for it, or you can get a really bad encoder if you want the label but not the quality. Getting a mature production grade, what I would call HEVC encoder at a sub 40K price point is going to take some time. But 2 to 3 years, not 10 years.
The technology is there, it's just a question. Or do you think you can
Well, the thing is, it takes a considerable amount of innovation to get a low latency, high compression efficiency encoder done. Right now, that's being done in software. When you do it in software and where a company's IP needs to be recovered and where there are only 2 or 3 people really doing it well, the prices will be high, right? I mean, these are the only 2 years they have to make money. After that, they're all in a race to the bottom. I can't really endorse anyone on a public forum, but find me afterwards and I can give you specs on everyone. So let me take him first and I'll come to you.
Just curious, do you have any market info on latency caused by HEVC, especially as it relates to live?
I do. Again, it's vendor specific, so I can't give it out publicly, but if you just find me afterwards, I'll give them to you.
Just a comment that I'm not advertising present, but our company is actually doing a software-based HEVC encoder.
Tell them which company you're from, because they may.
I'm from Roden Schwarz, which is a Munich-based company, but we're actually leveraging the Fraunhofer technology.
Right. Yeah.
As more high-end smartphones are coming out that can capture 4K video, do HEVC encode, decode, how do you see that driving the market? Because it's high-end smartphones this year, mid-level smartphones next year. What do you think that's going to impact?
You know, it's a good question. When I look at the power curve of 4K encoders in HEVC, it's not hugely friendly to the devices. So the decode, you can still last 6 to 7 hours. The encode, if you're trying to actually do it at HEVC optimal bit rates, is fairly brutal on those devices. And so, you know, right now it almost seems like you'd be better off eating the bandwidth and doing 4K and AVC, you know, as strange as that sounds, than it is trying to do it in software on a mobile device using HEVC. Now, you know, once someone like a Broadcom, and I'm speculating here, comes out with, you know, a silicon-based encoder, then that may change. But for now, I'm not seeing, I mean, and maybe 100 people or 1,000 people, right? Some kind of niche application range may use it, but for the broad majority, if you're video camming and you run out of battery in half an hour, that's not a good use case.
Yeah, I think a lot of it's going to be hardware accelerated.
Yeah, yeah. Someone else had a question somewhere. All good? All right, well, thank you everyone for your time. I really appreciate it.